Hi, I'm going to demonstrate our tool for modeling and verifying sensor networks running on TinyOS. Firstly, our tool allows simulating a sensor's behaviors. This is done by developing a compiler of NESC based on NESC semantics and an event-based model generator based on TinyOS execution model. Secondly, our tool models a sensor network as a composition of the models of all nodes with communications between them. Thirdly, our tool supports verification of safety and liveness of each sensor node as well as the whole network system. Verification includes checking data freeness, temporal properties, and state reachability. Our tool is integrated in PAT, Process Analysis Toolkit, a model analysis framework. After 3 years development, PAT now supports modeling and verification of systems of multiple domains, including real-time systems, probabilistic systems, sensor networks, and so on, each of which is developed as a module in PAT. And our tool is the recent progress implemented as the NESC module in PAT. Our tool is capable of modeling and simulating sensor networks built with various TinyOS applications. Several examples are included in our tool under this example menu, NESC Examples. Here is a sensor network with 3 nodes, each of which runs the Blink radio application chosen from TinyOS built-in example set. Our tools works for ordinary NESC code directly. No additional work is required. Here, each node maintains a counter, the value of which swaps between 0 and 1 periodically and sends it to the other nodes. After providing the necessary information, nodes, links, and applications, we can compile the system and simulate it. In the simulation window, we can choose either to simulate a sensor node or the whole sensor network. We can simulate the sensor network step by step, or we can ask the tool to perform an automatic complete simulation. Now we will verify various properties of a certain node or the whole network. Firstly, the verification goals should be provided. Here we have several assertions. The upper part is a single node verification which finds errors of a node's behaviors. Here we have deadlock freeness checking and a few temporal properties. This assertion means that whenever the counter of sensor 1 is set to 1, it will eventually be set to 0. And this one means that sensor 1 sends a message infinitely often, while the last assertion means that sensor 1 eventually receives a message. The lower part is network verification, which finds errors when all nodes execute and communicate with one another. The last assertion means that whenever sensor 1 sends a message, sensor 2 will eventually receive or lose the message. Now let's try verifying these assertions. When the verification is done, the time used and the number of states transitions explored will be displayed. The 9th assertion is not valid, and a counter example is presented. We can use the simulator again to have a graphical view of how the error happens. That is pretty much of our tool for modeling and verifying sensor network systems. Thank you for your time and attention.